So chapter 14, sections 1 and 2 deal with deciding whether or not there actually is a linear relation between two quantitative variables. And so all the inferential techniques that we've learned up to this point apply to this material as well. I thought what we would do is go through an example that illustrates everything that we learned in sections 14.1 and 14.2 in one example, and at the same time teach you how to build a model that you could use to figure out the price of a home, what a fair price for a home is in a particular neighborhood. And so rather than saying, hey, you're going to buy a house in Joliet, Illinois, let's try and live the dream here, and you tell me where your dream town is and we'll look for houses there. Price is no object. San Diego. Sounds great. So what we're going to do is look for homes in San Diego, California. And you can see here there are a lot of homes for sale. What we're going to use, this website that we're using is Zillow. And what Zillow does for you is it lists out homes that are for sale in different situations. But what I'm going to do, instead of looking at homes that are for sale, I'm going to look at recently sold homes. What Zillow does is they have some sort of a model where they figure out what they think the price of the home should be. They call that their Zestimate. Z with estimate on the end, a Zestimate. And so if we look at recently sold homes in the San Diego area, we're going to be able to see the Zestimate of that home, and then we're also going to be able to see the actual sales price. What's nice is that if you were to go out and buy a home or look at a home that's listed for sale, Zillow always gives you their Zestimate. Obviously, if the home is for sale, you don't know what the actual sale price is, right? So what we can see here is that there were quite a few homes that have sold in the San Diego area. What we might do here is narrow our situations down, right? So we might say, how many bedrooms do you want, Aaron, since you're the one that wants to live in San Diego? One bedroom? All right. And do you want a house and well, you don't want an apartment. Do you want you don't want manufactured or lot or land because you want to have a house. Townhouse, condo, house. Just a one-bedroom house. That should narrow things down. Well, not that much. So you can see we got quite a few homes still to pick from here. Well, I guess because it says 1+ bedrooms, okay? And so you're not going to find very many 1+ bedrooms there. And down here on the right, where I'm scrolling down, it's showing the sale price and then the corresponding Zestimate. See that? See how it says sold for $570,000? When I click on it, it's the Zestimate was $658,748. Follow? I don't think we're going to find very many one-bedroom homes in San Diego. I'm going to stick with a 3-bedroom, 2-bath because it seems to be pretty. Oh, there's a 1-bedroom. Sold for $330,000. Oh, it was a rental. That doesn't help us. So let's do that. Let's stick with 3 bedrooms, 2-bath. Right? By doing that, notice we're eliminating one of the variables that plays a role in the price of a home. Right? And so our data should have less variation in it because we're only looking at 3-bedroom, 2-bath homes. If we didn't have a requirement on the number of bedrooms, we'd have more dispersion. If I didn't have the requirement on the number of baths, I'd have more dispersion in my data. So we're kind of narrowing things down. And I'm not narrowing down necessarily neighborhoods here. These homes are all over the place. So I'm just going to pick this home right here. See how it sold for $570,000. The Zestimate was $658,748. What I'm going to do is open StatCrunch, and I'm going to build our data set. So I'm going to have a Zestimate, and then I'm going to have my sale price. So the Zestimate there was 658. I'll just say 659. We'll report our data in thousands. Is that good? And then the sale price was, what did we say it was? 570,000. See that? And we're just going to do that for randomly selected homes in San Diego. So we find another 3-bedroom, 2-bath. There it is, sold for 300,000. And the Zestimate was 372. So Zestimate 372, sold for 300. All right, so we have 13 homes. What we're going to do now is go through the entire data analysis process. First thing I'm going to do is draw a scatter diagram of the data, get a sense of what the data looks like. So we go graph, scatter plot. My X variable is the Zestimate. My Y variable is the sale price. So my X variable is the Zestimate. That's in thousands, right? My Y variable is the sales price, also in thousands. And these are homes sold in San Diego, California. Always want to title your graphs. Click compute, and there we have our scatter diagram. Based on the scatter diagram, what type of an association would you say exists between these two variables? And could you draw a straight line in here and have a pretty decent idea? All right, so probably a positive association between the Zestimate and the sale price, suggesting as the Zestimate goes up, so does the sales price, which makes sense, right? Calculate summary stats correlation. We can find the correlation between these two variables. Compute, and we see that the correlation is 0.783. See that? 0.783. Remember, what we can do is compare that result to that critical value in table 2. Remember, if the correlation, absolute value of the correlation is greater than the critical value in table 2, it suggests there's a positive association between the two variables. That critical value is 0.553. You all see that? And so because our correlation of 0.783 is greater than the critical value from table 2, that suggests there's a positive association between the two variables. This is what we did in chapter 4, right? And then the next thing that we did in chapter 4, if we noticed that there was positive association, or at least association between the two variables, we went ahead and found the least squares regression, where you go stat, regression, simple linear. The X variable is the Zestimate. The Y variable is the sales price. Now, in chapter 14, we can go ahead and do hypothesis testing on the data. Here, I would want to know, is there a positive association between the Zestimate and the sales price? Suggesting as the Zestimate goes up, the sales price is also going to go up. Down here, I can do all kinds of further analysis. For example, one graph that you're definitely going to want is the residuals versus the X values. You want your residual plot, because we had to check to see if the residuals are scattered, distributed evenly about that line y equals 0, where the residuals are 0. I also want to save my residuals, because I have to check to see if my residuals are normally distributed or not. I click compute. Okay, and I get all kinds of output. So what I'm going to do here is summarize all this in a document for you. So there's our data, copy, paste. We're basically asking this question here. Is there a positive association between the Zestimate and sale price of homes of 3-bedroom homes, 3-bedroom, 2-bath homes in San Diego, California? There's our raw data. If we go back here, I'll merge these two together. There's our correlation and scatter diagram. Right? And what we ultimately want to test here, the null, is that the slope parameter in regression is going to equal 0 versus the alternative that the slope parameter is greater than 0. The reason I'm picking a greater than 0 is because I want to know, is there positive association between the two variables? Right? Now, in order to conduct this test, we had certain requirements that had to be satisfied. We needed, first, that the residuals behaved in a way that the data actually is linear. We also needed the residuals to be approximately normal with no outliers. To check to see if a linear model is appropriate, if you go back to your StatCrunch output, remember we asked StatCrunch to draw a residual plot. There's your residual plot. In a residual plot, remember, you basically want these data to be evenly distributed about a horizontal line, y equals 0. Because right there is where the residuals equal 0. And you can see there is absolutely no pattern whatsoever in these residuals. Agree? There are not any residuals that are sticking out. The residuals are pretty much evenly dispersed across all values of the Zestimate. Because of that, this residual plot suggests that a linear model is in fact appropriate. The data are linearly related. So that's one thing we needed. The other thing, and that was section 4.3 where we covered this idea. The other thing that we needed is for the residuals to be approximately normally distributed with no outliers. That's the reason that I had StatCrunch save my residuals, because all I have to do is draw a QQ plot of my residuals to check for the normality condition, and then draw a box plot of the residuals to check for the outlier condition. So remember, to draw a QQ plot, you go to Graph, QQ plot of residuals. We want the correlation statistic, and I like to put the normal quantiles on the y-axis. Click Compute, and there is your QQ plot. Remember to check to see if the residuals are in fact normally distributed. We compare the correlation statistic of 0.981 to the critical value from table 6. We have 13 observations. For 13 observations, the critical value is 0.932. You all see that? There it is. 0.932. So because 0.981 is greater than 0.932, the QQ plot suggests that the residuals are normally distributed, which means that my response variable is also normally distributed, which is a requirement in order to do any kind of inference using student's t-distribution on the slope parameter. I also needed that my residuals have no outliers. You go to graph box plot and you can draw a box plot of your outliers. We draw the boxes horizontally and check the box to check for outliers. Click compute. Are you seeing any outliers in that box plot? No, no outliers in the box plot. And so our requirements for doing inference on the slope are satisfied. So now we go back to our StatCrunch output. There was our residual plot. Here is all the output that StatCrunch gives us. So in the StatCrunch output, there's lots of stuff going on here. First off, there is your least squares regression line. Y hat equals 0.6963x plus 81.6958. There's your correlation coefficient, 0.783. There's your coefficient of determination, r squared, 61.3%. Remember what that means. 61.3% of the variation in sales price is explained by my least squares regression line. If you wanted to be more particular than that, you could say 61.3% of the variability in sale price is explained by the zestimate, which means that, 38.7% of the variation in sales price is explained by other factors. The estimate of the standard error is 65.99. That's an estimate of the variability in Y, essentially, around the least squares regression line. So there is where the inference takes place, right? Our alternative is a greater than alternative. There's your test statistic of 4.171, right? And there's your p-value for the slope is 0.0008, right? Is the p-value low? Heck yeah, it's low. We would get a slope parameter of 0.69 or greater in about 8 of every 10,000 samples if there was no association between these two variables. And so clearly there is an association between the zestimate and the sale price. We're not going to worry about the analysis of variance output. So because there is a positive association between the zestimate and the sales price, it suggests that we could use this to make predictions about the sales price if we knew the zestimate. So Aaron, let's say you found a nice 3-bedroom, 2-bath home, right? So here, let's do this. We go back to Zillow here, and right now these are all the homes that have already sold, right? You're going to look for homes that are for sale now. And let's say that you want new construction. So these are all homes for sale. Ooh, you might as well live up here. Wait, where's no homes for sale near Coronado Island, which is super nice. Oh, he wants to live near the ocean. Okay, well that's fair. Here we go. Here's a 3-bedroom home. Plan 1 is the cheapie. 1.1. The estimate is $1.099539 million. Now I'm glad that you pointed this out because that's his estimate of 1099, right? Because we went to the nearest thousands. And if you look at our data, our model doesn't apply for that because you're way outside the scope of our model. And so I would not feel comfortable using our model to make a prediction for your very nice home. So you've now realized that new construction is probably not in the cards for you. So you and go with a used home. Let's see if we can find something where this estimate is. Or this, yeah, these are. See how what happens when you want to live near the water to the price. So you're now living inland, I'm afraid. How about this one? Not bad. Minya Lane. It's a darling home, they say. This estimate is $515,381. So we're going to go to StatCrunch, go back here to Options and Edit, and we're going to make a prediction. See this predictions part right here in StatCrunch? We're going to put in this estimate of 515.4. And then we're going to leave our level of confidence at 95%. Remember, we can make two kinds of predictions here. We can make predictions for the mean price of all homes, where this estimate is 515,000, or we can make predictions for the sale price of a specific home. When we make predictions, we can build intervals around those predictions. There are two types of intervals that we can construct. There are confidence intervals about the mean response. So that would be a confidence interval for the mean value of all homes where this estimate is 515,000. Or we can make a prediction interval, which is probably more what Aaron's interested in, which is a confidence interval for the price of a specific home. So we click Compute. And down here are the predicted values. Y'all see that? So this confidence interval is the mean price of all homes whose estimate is 515.4. And there's the prediction interval for any particular home. And so we would say something like this. We are 95% confident the mean price of all 3-bedroom, 2-bath homes in San Diego, where the estimate is 515,400, is between what, 390.8 thousand and 490.4 thousand. Kind of spread out. Why? Because our standard error is pretty high, right? We are 95% confident the sale price of a particular 3-bedroom, 2-bath home in San Diego, where this estimate is 515,400, is between, now we have an even wider range, 287.0 thousand and 594.1 thousand. And so you can see there's a, when you make a prediction about a particular house, your interval is much wider because there's more variability associated with individuals than there are with means. And so you would feel comfortable paying somewhere between those two dollar amounts for that darling house on Minya Avenue. But your target price would be $440,585. See that? That would be your target price for the home. What are they asking? $548. Right? So you're going to lowball them based on your model. And you would say, look, I think you're way overpriced based on my model of homes that have also sold in this neighborhood and there's estimate. So you actually have data to back up your and support your offer.